Welcome to JAMB Chemistry Class. In this video here, we're going to focus on empirical and molecular formula. And empirical and molecular formula is one aspect of chemistry calculation you must understand very well, because questions do come out in the JAMB examination, and also you can also see it in pursuit ME. So what you're learning now is both what JAMB examination and pursuit ME, and you also see it in year one when you get admission into year one. So you will not pay close attention here. I'm taking my time to dissect this topic for you, so that by the time you finish watching this video here, you should be able to understand every single thing and calculate every single calculation under what empirical and what a molecular formula. So I want to talk about what the empirical formula, what the molecular formula, different between two of them. We want to look at what calculation problem, all the calculation problem under what empirical, what a molecular formula. I will give you what step by step on how to understand this topic. So what you want to do here is to what, make sure you have to prepare your notebook so you can take down every single thing. So let's get into it. Before we start the class, if you know that you are new here, please consider subscribing to this channel, because this channel is focused on helping you to pass your JAMB examination. For this video on what math, chemistry, and physics, right? So if you want to pass your JAMB examination very well, you want to get tips, you want to get strategy on how you can study and understand to pass your exam in one sitting, then you want to subscribe to this channel here. If you have any question, only leave it at the comment section, and I will respond to each of your question. So let's get into it. So first of all, what is empirical formula? You have to understand what empirical formula. So please take it down. The empirical formula of a compound gives the simplest whole number ratio of elements in that compound. The word simplest whole number ratio, simplest. That is, simple means that you cannot divide this back, right? If, for example, you have two compounds, here we have H2O2, and here we have C3H7. So now let me explain the concept of empirical formula here. Now, here we have, in this compound here we have two atoms of what? Hydrogen, and two atoms of what? Of oxygen here. Is this the simplest whole number ratio? The answer will be no. Why? Because 2 can go into this 2 here, and 2 can go into this 2 here, right? If 2 should go into this one here, how about H1? If 2 should go into here, how about O1? Right? So because this can be further be simplified into this here, I can remove this one, right? So this is not empirical formula. Do you understand? Because this is not what the simplest whole number ratio. This is what is my empirical formula. So this is the empirical formula to this guy here, right? Now look at what second question. Here we have C3H7, right? Now, if I should ask here, can I divide this thing down? Can I break this down to get on that one here? The answer is no. Why? Because there's nothing that can go into 3 and 7 together, right? So this guy is what is this guy you are seeing here is what is empirical formula. Just now, so empirical formula simply means what? The simplest ratio, the simplest whole number ratio of each of the elements in that compound. So you cannot subdivide, right, or break it down, right? That is called empirical formula. I hope you understand it now. Look at molecular formula here. What is molecular formula? So please take down. The molecular formula of a compound gives the actual number of atoms of each element in the compound, right? So the actual numbers of what? Of the elements, numbers of atoms, the actual numbers of atoms of the elements in that compound is now what? The molecular formula. So for example, here we have, let me give you a good example here. We all know water, right? H2O, water. H2O, right? If you look at water here, can you subdivide this one down? The answer is no, right? So does it mean that water only have empirical formula? The answer is no. This is the molecular formula of water, and also this is the empirical formula of water. It means that there are some compounds that their formula compound only have simplest ratio, right? So the molecular formula is also the same type as the empirical formula. Like for water only contains 2 atoms of hydrogen, 1 atom of oxygen, right? Now this one is the molecular formula of water. It's also what the empirical formula of water. Do you understand? Let's take an example here. Peroxide, H2O2, right? H2O2. Now let me ask you here, H2O2. Is it empirical formula or molecular formula here? Right? Now, this guy can split it down to what? HO, right? HO, right? This is the actual or whole number ratio of each of the elements of the compound here. This is what is the molecular formula. Molecular formula. Right there. The molecular formula of this compound is, so for here, you now get the empirical formula. This is the empirical formula. Right there. So molecular formula, empirical formula. This guy you cannot split it down. So you also have this one here, H2O. So molecular formula, empirical formula. Just for example, here we have benzene. If you look at benzene was 6,6H6. Here we have C6H6. Right there. Now, can you split it down? Like, can you break it down? 6 can go into this place and 6 can go into this place, right? What are you going to get? I'm going to get CH, right? So this is what my molecular formula. Right there. Why is what is my empirical formula? It's okay. As it as that. So when two compounds are being given to you, or when group of compounds are being given to you, I say select the one that is empirical, select the one that is molecular formula. From there, you share what the simplest whole number ratio. From there, you share the one that are not simplest whole number ratio, the actual. Do you understand? So to really get it here, the molecule that I can split down is what is a molecular formula. Why the one you cannot easily split down is what is empirical formula. Why the one you cannot split down is what empirical formula. So, for example, here we have these two things. If you are comparing two compounds here, for example, here we have C6H12O6 and CH2O. Of course, if they should ask here, which of this is empirical formula, which of this is what is molecular formula? It's very easy. Now, here we have 6,6H12O6, right? And this was CH2O. Of course, 6 can go into here 1, 6 go into here 2, 6 go into here 1, right? This is what my molecular formula. It's okay. Why is what is my empirical? As easy as that. As easy as that. It's not difficult. What about if I ask you here N2H6? What is going to be my empirical? What is going to be my empirical formula here? If you ask here, what be my empirical formula here? Leave it at the comment section. N2H6 is a molecular formula, right? Is a molecular formula, right? Now, what can I split it down? The answer is yes. 2 can go into here, 2 can go into here. So if 2 should go into here, have N. If 2 should go into here, have what? N1. If 2 should go into here, have what? 3. N1 H3, right? So it's going to be NH3. So what does it mean? This one is my empirical formula to this molecular formula. As easy as that, right? Now, if I show something like this again, C5H12O3. Does this have empirical formula? It does not have empirical formula because not can go into them, right? So you can say that this one is the empirical formula. This is also what the molecular formula. Do you understand? So I believe you have clearly understood the concept now, right? So these are the concepts. This is how to understand what is called empirical formula and molecular formula. It's very important calculation you need to understand. So let's move to the calculation aspect now. How to calculate empirical and molecular formula. Now that after I start giving you all the rules here, what I'm going to do here is to give you question and explain the concept for you very well. Let's get into it. Our first question in this video here. Now from the question, I'm going to give you all the steps in order for you to calculate empirical and molecular formula here. From those steps, I'm going to show you now what you are supposed to do and what you are not supposed to do. Right? Please pay close attention here because I don't want to just give the step Now start bringing question. From the question, I want to what give you the step. From there, you understand it better, right? So make sure you follow me closely here. So let's look at the compound here. They say that a compound contains 40% carbon, 6.67% hydrogen, and 53.33% oxygen. Find the empirical formula of the compound. Now, in the calculation of empirical molecular formula, you must first calculate what the empirical formula. From the empirical formula, now move to what molecular what formula. Just now. So for every question given to you, you must first calculate what the empirical formula. And for you to calculate the empirical formula here, now they can either give you the mass of each of the elements that make up that compound, or the percentage by mass, right? So it can either be given the mass of the compound, so mass of each of the elements. But if you check very well now, this compound contains 3 different elements. It contains carbon, hydrogen, and oxygen. Is an organic compound, right? So yeah, they give us what percentage by mass or percentage composition by mass. Just understand? Now, when percentage composition by mass is given to you in a compound, you use that as well as mass. Idea, because the first step for you to calculate empirical formula is to calculate the mole of the compound, right? So it calculate what the mole of the what elements that make up what that compound, right? After you calculate the mole of each of the elements, what you want to do here is what divide through by the simplest mole to get what their ratio, right? It's from that ratio that is when you are going to go get your empirical what molecular. That's when you want to get your empirical what formula. Do you understand? So when the question is being given to you, therefore solve all these things together if it's up to 100%. Idea. So if it's percentage here, if the first one to do here is what? Sum all their percentages. So here we have 40 plus 6.67 plus 53.33. Everything is 100, right? So when percentage be given to you first, to know if the question is correct or not, because if it's not up to 100%, then the question is not correct. And hence you are solving, you are just like wasting your time. So the first one to confirm first what is to like confirm if everything, when you sum everything is what is 100%. Just so 40 plus 6.67 plus 53.33 give you what 100% straight. So the question is accurate, right? So now I'm going to use table here. So you have elements. Elements, and here they give us 3 elements: carbon, hydrogen, and oxygen, right? So what we want to do here is just to use what their symbol, right? Carbon, hydrogen, and oxygen, right? So from here now, what are the percentage by mass? Idea. What are the percentage? So carbon is what is 40, hydrogen is what is 66.67, right? Then oxygen is what is 53.33. Is okay. There's no point putting the percentage again because this year I always say percentage. So that means what percentage of this guy means percentage. So there's no point to put the percentage again. Do you understand? Now the elements and percentage here. So the next step is to get what mole. Idea is what get mole. If you have been following my YouTube channel here, we have done formula, we have done what mole concepts. We have done what mole concept calculation. So if you have not checked out that video here, please go to the description below. You see mole concepts. It's about 45 minutes or 15 minutes video. It explains step by step how to calculate what the mole concept calculation. Everything I explain everything very well. So please check it out. So here we have mole. How do you calculate mole here? Mole is always equal to what mass over what molar mass. For this case here, we are using what the atomic mass because we only talk about one atom. So it's going to be what atomic mass, mass idea. So the mass we are going to use here is going to be the percentage because here we have percent by mass. So instead of gram big so they give our percentage. So we are going to use it in the place of mass, right? So you want to get the more here. Now, what is the atomic mass of carbon? The atomic mass of carbon C equals to what is 12, hydrogen equals to what 1, oxygen equals to what 16, right? Hope you can recall this one here. Very important. Although in the exam you'll be giving, but you have to know them in case it's not be given to you. right? So now let's get the mole here. So it's going to be mass over what? The atomic mass. So it's going to be 40 over what? Over 12. That is meaning. Here we have what? 6.67 over what? 1. And here we have what? 53.33 over what? 16, right? So let's bring out our calculator. Let's use our calculator here. So here we have 40 divided by 12. What do you have? 3.33. 3.333. So now, for accuracy's sake here, leave it in 3 decimal points. Either for accuracy, leave to what 3 decimal points. So here we have what 6.67 divided by 1. Here we have what 6.670. 3 decimal points. Do you understand? Yeah, is 16, right? 53.3 divided by 16. What do you have here? Here we have 3.331. Idea for accuracy's sake. Now, once you have got this one here, you are like you Empirical formula. You are like, let me just say you are 8% done. The next one to calculate here is what mole ratio. Remember, they are what moles, mole and what and mole, right? They are mole, right? So the next one to calculate is what is called mole ratio. Mole ratio. Idea that carbon ratio, hydrogen ratio, what also here. How do you get this mole ratio here? It's very easy. It's very easy, right? Divide by what? By the simplest mole, right? Here we have 3.333, 6.670, 3.331. So 3.331 is the simplest mole, right? So I want to divide through by what? By the simplest mole. So it's going to be 3.333 or what? 3.333 ratio, right? 6.670 over what? 3.33. Sorry, 1. Here it's supposed to be 1. 1 ratio 3.331 over what? Ratio over 3.331. Of course, it's going to be 1 ratio 6.670 divided by what? 3.331. Here we have what? 2 ratio what? 1. Is okay. So these are what my ratio here. It means that if you check it very well, it means that carbon ratio, hydrogen ratio, what oxygen is what? 1 ratio what? 2 ratio 1. What does it mean here? It means that 1 is for here. So my empirical formula here, empirical formula is very easy now. Empirical formula is going to be what? It's going to be what? C1H2O1, right? But you can see that there's no point of putting the 1 here because so it's just going to be what? CH2O. This is what my empirical what formula here. So you can see I'll be able to what to get what my empirical what formula here, right? So now the next what we'll do here is to calculate the molecular formula. You understand? It is from the empirical formula we have to get what the molecular what formula. So how do we get what the molecular formula? It's very easy. It's very easy. So let me just try this place out. So to get my molecular formula is very easy here. You can say as empirical formula N equals what? The molar mass. Idea. Now this one means what? The ratio. Idea. This one means what? The ratio. Now it is what determines the molecular formula here. So here I have calculated what my empirical formula, right? So it's going to be CH2O. Here we have N, right? Equals what? My molar mass is what? My molar mass is what? Is 180. So the goal here is what? Is to look for what? My N. So once I look for my N, remember here is 1, here is 1, right? Once I look for my N, I will multiply it with this one, with this 2, and with this one. Then I will now get what my molecular formula. Do you understand? So now let's calculate the molar mass of this empirical formula here. This is what? The molar mass of the molecular formula. idea of the entire compound. So, but my empirical formula also has its own molar mass, right? So let's calculate it here. Here we have 12 times 1 plus what? 2, 1 times 2 plus 16 times 1, right? Here we have 180. 180. So what happened here? You got to go 12 plus 2 plus 16 equals to what? 180, right? So let's add it together. Here we have 12 plus 2 plus 6 plus 16. Here we have 30. 30 what? N equals to what? 180. Divide both sides by what? 30. So 180 divided by 30. Here we have what? 6. So my N is equals to what? 6, right? So how do I now get my empirical formula, my molecular formula here? So my molecular formula is now going to be, molecular formula equals to what? The empirical formula, C1H2O1. Here we now have what? N, right? But my N is already what? 6. So you remove it here, put what? 6, right? So my molecular formula here, equals to what? So 6 times 1 is what? Is 6 H. 6 times 2 is what? Is 12. 6 times 1 is what? Oh, what? 6, right? So this is what my molecular formula. So now let's look about 2 more questions. So going to be question 2 and what? Question 3, right? So let's solve this question. Let's look at what the first question. This is a compound contains 38.77% calcium, 90.97% phosphorus, and 41.27% oxygen. What is the empirical formula of the compound, right? Or of the sample? Now, they only ask us to look for what the empirical formula, no molecular formula, right? So now, there's a reason why I've got this question here, because this question is a little bit tricky. So please pay close attention. By the time we continue solving this here, and I'm going to show you some mistakes some they make when they solve this problem. So please pay close attention. The third one is just like what you have done here, but here they gave us what? Vapor density instead of what? Molar mass. So when vapor density they give to you here instead of molar mass, how do you calculate what molecular formula here? So please pay close attention here, because these are the type of questions you likely see here is JAMB examination or your post-GME examination. So you want to pay close attention here. So let's look at the first one here, right? First of all, sum all these things together. It is up to 100%. So you have 38.77 plus 90.97 plus 41.27. So everything is 100. So we're on track here. So here we have elements. We are going to use table. Table will make it more easier for us, like what I said. So the first one is what is calcium. Is okay. The second one is what is phosphorus. The third one is what is oxygen, right? So look at percentage by mass. Calcium is what is 38.77, right? Phosphorus is what is 19.97. Oxygen is what is 41.27, right? Now next one to calculate is what is mole. How do you calculate the mole here? The mass over what molar mass here. So the percent by mass is what? So the mass of calcium, phosphorus, and oxygen are all these ones here, right? So remember, like what I told you, mole equals to what? Mass over what molar mass is okay. Mass over molar mass. So that is going to be what? 38.77 over what is the atomic mass of calcium is 40, right? For the other one here we have what? 19.97 over what? 31, right? Also, that what their atomic mass of each of the element here. The oxygen is what is 41.27 over what 16. So let's use our calculator to get our answer here. So you have 38.37 divided by 40. Here we have what 0.9692, right? So now we can leave to what to 3 decimal point. Let's leave to what 3 decimal point. 3 decimal point is okay. Do you understand? 90.97 divided by 31. So we have what 0.644, right? Here we have mole. They are all mole. The unit is what is mole. The next one is what 41.27 divided by what 16. Here we have what 2.579 is okay, mole. Now the next one to do here is to what is to get what the mole ratio. Getting what the mole ratio, right? So next to what get the mole ratio. And how do we get the mole ratio? Divide by what? By simplest mole, right? Here we have 0.9969. Here we have 0.644. Here we have 2.579, right? What is simplest mole here? So what is the simplest mole? My simplest mole is this, right? So it's going to be calcium ratio what? Phosphorus ratio oxygen equals to what? Divide by the simplest mole here. So you want to divide through by this value here, right? 0.969 mole over what? 0.644 mole ratio what? 0.644 mole over what? 0.644 mole ratio 2.579 mole over what? 0.644 what mole, right? So let's do the calculation here. 0.966 divided by 0.644. Here we have what? 1.5 ratio. 1 ratio. Here we have 2.579 divided by 0.644. Here we have what? 4. Now, here we now have 1.5 ratio, 1 ratio, 4. Now, this year, last mistake of students will make mistake here. You know, in mathematics, please pay close attention here. You know, in mathematics, when you have 1.5, you are positive to 2, right? The mistake a lot of students will make is that they will approximate this 1.5 to 2. Now, when you are solving a empirical formula here and you got or you solve and you now get 1.5 as one of the ratio, now you don't approximate to 2, right? Now you multiply by 2. Just and so when you have 1.5, when you have 1.4, 1.5, 1.6, now you don't approximate. So when you have 1.4, you multiply by 2. When you have 1.5, you multiply by 2. When you have 1.6, you multiply by 3. Just and so when you have something like this, 1.5, you don't say is now 2 ratio 1 ratio 4. No, you fail it. Just so whenever you have 1.5 as one of the ratio, you multiply by 2. So you are going to multiply by 2. Now, as you multiply by 2, it's going to affect everything here. So the ratio of 1.5 as one of the ratio, you multiply the whole of them to be what? To be 2. It's okay. So 1.5 times 2 is going to be what? 3 ratio 1. 2 times 1 is what? Is 2 ratio. 2 times 4 is what? Is 8. Do you understand? In the exam, you might see like 2 ratio 1 ratio what? 4. Now, this will be one of the options in your exam, but this is the actual answer. So this is what is the actual answer. Do you understand? So the empirical formula is what? Which was calcium 3, phosphorus 2, then oxygen 8. This is not the answer. Do you understand? Not calcium 2, phosphorus 1, oxygen what? 4. This is not the answer. Why? Because say we have 1.5. So whenever you have 1.5, where I solve a empirical formula here, now version of this 1.5, you multiply by what 2. This time what the correct answer here. This is the correct one. Do you understand? Don't have to the mistake the exam and see 1.5 and multiply by 2. You fail it. Do you understand? So this is it for this one here. Now let's look at what question 3, which is going to be the last one. Question 3. So that look at what question 3. Question 3 is not like is not different from the ones we have done, right? The only difference here is that here we now have what vapor density, which I'm going to show you how to do that here. So I believe when something like this begins, you can calculate what the empirical formula, right? So let's calculate the empirical formula of this compound here. They say a compound contains 30.4% nitrogen and 69.6% oxygen. When you sum them together here, is it going to give you 100? Let's sum them together here. 30.4 plus 69.6, 100, right? Correct. So elements, here we have what nitrogen. You only use what the symbol, and oxygen, right? So percentage by mass, percent by mass, here we have what 30.4. Oxygen is what 69.6. So let's look at what the mole, right? Now, what is the atomic mass of nitrogen? Nitrogen is what is 14. Oxygen is what is 16. Is okay. That's what you want to understand there. So you're going to be what 30.4 over what 14, right? Here we have 69.6 over what 16. So here we have 30.4 divided by what 14. Here we have what 2.171 mole, right? Here we have 69.6 divided by 16. We are what 4.350 mole. Is okay. Next we want to do here, so we'll get what the mole ratio divided by the simplest. The simplest is this guy here. So mole ratio, right? Which is what? Which is nitrogen ratio what oxygen going to be 2.17 mole over what 2.17 what mole ratio. Here we have what 4.350 mole over what 2.177 what 1 mole. Here we have 1 mole, right? So you're going to be what 1 ratio. So we have 4.350 divided by 2.171. Here we have what 2. It's okay. So my empirical formula here, empirical what formula is what N1O2. Is okay, which is what NO2. Can you see that? Now, here they give us what? They say we calculate the molecular formula, right? So remember to calculate what my molecular formula here is very easy. My molecular formula is what is very easy, right? Remember it's supposed to be what empirical formula. Here we have n equals what molar mass, right? It's okay. Yeah, instead of them to give us molar mass, they give us vapor density. So what is the relationship between molar mass and vapor density? Understand is that molar mass is equal to 2 times vapor what density. Are you there? So you have to text this down here. Molar mass equals to 2 times what vapor density. Please pay close attention to this. So my molar mass now equals to 2 times what my vapor density 23. 23, right? So going to be 2 times 23, here we are what? 6, right? So now, that is my molar mass is this here. Where empirical formula is what? NO2 N equals to what? 46, right? So let's calculate the molar mass of this empirical formula here, right? So if you calculate the molar mass here, 40 times 1 plus what? 16 times 2 N equals to what? So let us say square bracket, right? Sorry, here. Equals to what? 46. So here we have 60 times 2 plus 14. Here we have 46. Here we have what? 46. So here we have 46 or N equals to what? 46. So if you should divide both sides by what? 46 here, or N equals to what? 46 or what? 46 N equals to what? 1. So if you check it very well, my molecular formula is also the same as the empirical formula. Just that. So my N, so my molecular formula is what? The C, what here we have NO2 1. Is okay. N. My N is what? Is 1. So here is what? Is 1. What happened here going to be 1 times 1 is what? NO2. Is okay. So my empirical molecular formula are the same. So we have come to the end of this class. If you have any question, can leave it at the comment section. It's very important. If you have any question, leave it at the comment section. And if you're not subscribed to our YouTube channel here, kindly subscribe to our YouTube channel. If you have any question, like what I said, leave it at the comment section. If you want to join our private online class, send me a DM that you want to be part of our JAMB private online class where I teach you regularly. Right? Thanks for watching. See you in my next video.